Today we're going to have a look at surds and in particular how to simplify surds. First of all, what are surds? Well, it's an irrational number and it's going to have a square root sign or a cube root or even a fourth or fifth root sign, but it cannot be simplified to a rational number. That's important. So for instance, the square root of 3, the cube root of 10, 5 times the square root of 7, these are all examples of surds. Now if I write them as a decimal and you use your calculator, they're going to be decimals that continue on forever but never repeat. So they're examples of surds. We've got some other ones that appear like they are surds. Square root of 81, cube root of 125, square root of 1.44, and the square root of 4 over 25, but in fact they're not surds. And the reason why is that the square root of 81 is 9, which is an integer. Cube root of 125 is also an integer. 1.44, the square root of that is 1.2, which is a decimal that terminates or ends. And the square root of 4 over 25 is just 2 over 5. So that can obviously be written as a fraction. I can also have decimals in there that repeat, and they would also be rational numbers. So there's an example of surds and ones that appear to be surds but in fact are not. So let's look how we simplify surds. Well, not all surds can be simplified, but we're going to focus on ones that basically can. But what we've got to look for is the highest square factor of the number within the root symbol. Now most of the times when we're simplifying surds, we're just going to focus on, in this course, square root symbols. We're not worried about cube root and fourth root. So we're just going to have a look at how we simplify square root surds. What do we mean by square factors? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc., etc. So they're square numbers, and we want to make sure that we can find a square factor of the surd so that we can simplify. We don't want 1 though, because the one, when we find it as a factor, is not going to change anything. So these are the ones we're going to focus on here. So if a square factor exists, then we rewrite the surd as a product of its factors. So let's have a look at an example. For instance, the square root of 18. Well, the highest square factor of 18 is 9. So I'm going to change the square root of 18 as a product. So 18 is 9 times 2. And 9 times 2 is still underneath the square root symbol. What we can now do is we can separate the surd into a product of 2 surds. So I'm going to change this square root of 9 times 2 into the square root of 9 times the square root of 2. We're allowed to do that with our surds. The next step is evaluate the first surd. Now I like to make sure I do my square factor first. It doesn't matter if we've got them round the other way, it just means these are going to be round the other way. But you'll see why I prefer to do this first in a moment. So square root of 9 is 3. Square root of 2 I can't find nicely. It's that big long decimal. It's that surd. And just like in algebra, I don't need the times sign in between. So I can now change that to just 3 root 2. Now if I had them the other way around, I won't write root 2 3. We write them, our common way is also number first before the surd. Okay, and that's how we basically simplify our surd. So let's do some examples. Here's 3 of them. We're going to simplify each of these: the square root of 75, the square root of 80, and 4 lots of the square root of 98. So again, what we need to know are our square factors, and again, ignore our 1, because if I change that to 75 times 1, it doesn't change anything. So let's have a look. 75. Our biggest square factor that is there is 25. So I'm going to change square root of 75 to 25 times 3. Now let's separate them. Square root of 25 times the square root of 3. Evaluate the first one. Becomes 5 times the square root of 3. and then we don't need the time sign in between. So there are our steps, and with practice we can actually skip some of those steps, but only when we practice it a fair bit. So let's try next one, square root of 80. Well, 4 is a factor, but we want our highest factor, and it happens to be 16. So we're going to change that to square root of 16 times 5, separate them, evaluate the first one, and then rewrite it without the time sign. So we get 4 root 5. So square root of 80 is the same as 4 root 5. Now, if I didn't choose the highest one, then what I would have here is 2 root 20, and then 20 has a factor of 4, and then I can simplify that a bit further. So try and find the highest one in the first place. It makes it easier. So the next one doesn't look like 98, has a nice factor. 4 certainly isn't, 9 isn't, 16 isn't. So if we keep going, we might want to practice on our calculator dividing this by some of these, and the highest one is 49. So I'm going to change that to 4 lots of. That's what the 4 out the front means, 4 lots of. The square root of 49 times 2 gives me the 98. Now let's separate. Square root of 49 is 7. I can multiply these numbers together. 4 7s are 28. And then again, I don't need my times sign in between the surd. So I then get 28 root 2. So that's the basics on how we simplify surds. Let's have a look at another example which is slightly different. So this time, we've got our answer here already simplified. We want to put it back to a single surd. So we don't want to multiply out the front here. And sometimes you might see this question written like this. So 6 root 7, we want to change it back to just a single surd like that. So it involves doing the opposite. So let's start off with writing the question. And this time 6 is the same as square root of 36, and it's timesing that 7. So let's write that. So this is 6 and it's timesing the root 7. Bring them together and then just multiply what's underneath the square root sign, and we get the square root of 252. So hopefully you found this useful, but if you really want to get better at these surds, then you need to practice, practice, and then practice again. And then that way you'll find surds so much easier. So I hope you found this video useful.